let's see what is a domain. Domain is a set of real numbers that the variable is permitted to have. Okay, so this explains where does the x in your graph exist. Let's see a few cases of domain here. The first one is polynomial. Polynomial is a set of functions where the power is an integer and it is positive. So for example, fx equal to x, because this is x power of 1. So for this question here, 4x cubed minus 2x plus 9, this is also a polynomial with the highest degree is 3. And for example, this one, fx equal to x squared plus 2x minus 6, this is also a polynomial because you have a positive integer as your highest power. So for all cases here, for polynomial, domain is always a real number. Okay, so your domain take the value from minus infinity until infinity. This is also the same case for odd roots. Okay, if you have radical and the root is odd, either 3 or 5 or 7 and so on. So for these cases, the domain is always a real number. Next, let's see for fraction. For example, the simplest one I can give you is fx equal to 1 over x. Okay, so you must take note that for fraction, denominator cannot be equal to 0. So in this case, your denominator is x, therefore x cannot be equal to 0. So let's graph a number line, and this is your 0. So you have all real number, but you must make a whole at 0. So the interval form of your domain is minus infinity until 0, and then you must stop here, continue union 0 until infinity. So for the next question, let's take the denominator. Because you have fraction, denominator cannot be equal to 0. Therefore, let's bring 3 here. Then x cannot be equal to negative 3. So just draw a number line. So this is all real number, but you must make a whole at minus 3. So your answer is from minus infinity until minus 3, union minus 3 until infinity. Next, let's see this question here. fx is 2x over x minus 6, x plus 3. Okay, so for 2x, you don't have any problem. This is just polynomial, but you must take care of your denominator. So the first denominator, x minus 6, cannot be equal to 0. So solve x cannot be equal to 6. Then we must intersect, and another one is x plus 3. Here cannot be equal to 0, so x cannot be equal to negative 3. So to conclude your answer, this is all real number, but you must make a whole at minus 3 and also 6. Therefore, your answer is minus infinity until minus 3, union minus 3 until 6, union 6 until infinity. Now let's see the case for radical for even roots. Okay, so if you have even root, for example, square root, root 4, root 10, and so on. So what you should do is all terms under the radical must be more or equal to 0. So this is the easiest one here. Fx equal to square root of x. So just take everything down here. Inside your radical x, it must be more or equal to 0. Okay, so that is the domain. So let's draw here for 0, you must take included and all. Why you must take a positive number? Because you cannot have negative number inside your square roots, or else it will be a complex number. So we are being very careful with even roots. All inside the radical must be more or equal to 0. So the answer, the domain is from 0 included until infinity. Let's see this question here. Fx is square root x minus 1, x plus 5. So what you should do is, let's take the number under the radical and make it must be more or equal to 0. So this is a quadratic. Easiest way is just to draw the smiley graph. So let's put minus 5 here and 1 here. And you want to take the positive side. Therefore, your answer is minus infinity until minus 5 included, union 1 until infinity. So let's see this question here. Fx equal to square root x plus 9. So what we should do is take the term under the radical. So x plus 9 should be more or equal to 0. And then just bring 9 over here. So x must be more or equal to minus 9. So if you want to draw the number line, this is minus 9 included going to the right. Therefore, our final answer is minus 9 included until infinity. Alright, next case, let's see radical at denominator. So what happened when you have a radical and it is at your denominator? So this is the easiest question that I can show you. 1 over square root of x. So we already learned that all terms under the radical here, it must be more or equal to 0, right? It must be a positive number. However, denominator cannot be equal to 0. So since this is at denominator, it cannot be equal to 0. Therefore, the domain is just x more than 0. You must get rid of the equal sign. So the answer for this one is just 0 not included until infinity. Let's see the next question here. You also have radical at your denominator. Okay, so just take everything under the radical. It must be more than 0. So actually this is more or equal, but denominator cannot be equal to 0. So this is just left with more than 0. So let us solve. Just bring 12 to the other side since this is a linear inequalities. So x is more than minus 12. And then you can draw minus 12. This is more not included. So your interval form is minus 12 until infinity. And this is not included. Let's see this question here. You also have radical in your denominator. So just take everything under your radical. And it must be more than 0. So actually it is more or equal to 0, but again denominator cannot be equal to 0. So this is just more than 0. So this is quadratic inequalities. The easiest way to solve it is to draw a smiley graph. Let's put the root 2 and another root is 7. Then let's take the positive parts. And you must make sure that this is not included. Let's conclude our answer. This is from minus infinity until 2. Union 7 until infinity. Now, what if you want to combine the intersection? So, for combining intersection, you must take care of the domain in the numerator and you must intersect with domain in the denominator. So, let's see here, domain for your numerator, you have square root of x. So, the term under the root, it must be more or equal to 0. And then let's intersect. And another one, you have x in your denominator, so x cannot be equal to 0. So let's draw a number line and let's together combine these two, okay, intersect them. So let's draw the first one. X must be more or equal to 0. So this is your 0, so include it to the right. And this is all real number, but you must make a whole at 0. So the intersection is all the numbers on your right hand side here. So you can see that at the intersection here, 1 is included, 1 is not included. Since this is strict, so we must take not included. So the answer is 0 until infinity. Now let's see the next question. You have combination of this numerator and also denominator. So for numerator, it is square root function. So we know that the number under the radical must be more or equal to 0. So this is just linear inequalities. Let's solve. Bring minus 3 on the right hand side. So we're finished with this. Let's see the next one. This is for your denominator. Okay, let's focus on this number here. So x plus 3 and x minus 6 cannot be equal to 0. Therefore, x cannot be equal to minus 3. And you must intersect it with x cannot be equal to 6. Next, you also have a square root in the denominator. So the term under the square root, it must be more or equal to 0, but denominator cannot be equal to 0. So you're left with just x more than 0. So now let's intersect everything and then we can find our answer. Let's see the first one, x must be more or equal to 3. So let's draw a 3 here. So this is more or equal to 3. Finish with that. Let's see the next one. X cannot be equal to minus 3 and x cannot be equal to 6. So this is just a real number. However, you cannot be equal to minus 3 and cannot be equal to 6. So you have a hole at these two sides here, and then the rest of them is included. So let's draw like this. Next, the last one, x must be more than 0. So let's graph it. X must be more than 0. So 0 is somewhere here. It must be more than 0. So now let's find the intersection where does all three graph is together. So you can see this is the first intersection that we find intersection, but here you must stop for a little bit and then we can continue. So it is this part here and then continue until infinity. So your final answer is 3 included, up to 6 not included, union 6 not included up to infinity. So this is your final answer.